Okay, a little bit of some questions came up on the homework. I'm going to do two of these. I already wrote them out. So the first one is the water tower question. I saw a lot of questions, or heard a lot of questions during the seminar on this one. Okay, so I want to point this out. We first need to find the work required. So we have to integrate to find the work required for the tube, and then the actual tank on the top. So if you look at this, we first need to find the work required to just pump the water through the tube and then fill the tank. So I'm first going to do this, and the tube or the base of it, or whatever you want to call this going up the top, is only 4 inches wide. So that means its radius is 2 inches. But everything is feet, so I got to change it to feet. So it's 1/6 of a foot. Okay? So my cross-sectional area is going to be 1/6 squared times pi. Multiply times the density. And then since I'm filling it from the bottom, it's a distance y from 0 to 360. So we're just going to take care of that work. And I get the 352,000 foot-pounds on that one. Okay? The second one, now I got to figure out how much work it is to fill the tank. Granted, it's got to still come up this height, so I'm going to be integrating from 360 to 385. Yes, you could do it from 0 to 25 and do it as y plus 360 also. But our cross-sectional area there now is 100 pi times the distance y again, and the amount of work there is huge. Okay, so now I added those together, and I get this. I don't know, what is that? It's like 182 million foot-pounds of work. Okay? We had a pump that could pump at a rate of 1,650 foot-pounds per second. So I'm going to divide that to figure out the number of seconds that pump would have to work, and it's about 110,000 seconds. Okay, now I'm going to convert that to be hours, and there are 3,600 seconds in an hour. So I get 30.7 hours, which is about 31 hours. So it takes almost 31 hours to pump all that water and fill it up. Significant amount of time. Okay? All right, the second one I wanted to do was out of the review. It was the base of a solid, was an area of a cross-section perpendicular to an x-axis for semicircles. Okay, here was your top, here was your bottom from 0 to pi. All right, so what we have to do is, first of all, we have to remember that we compute everything as a square. Okay, that's how we've done it. And we compute that volume based on squares, but then we convert them to other shapes. And the ones we have to remember are semicircles, pi over 8, equilateral triangles, √3 over 4, and isosceles right triangle is 1/4. Okay, so here's my region. And remember, we are taking our vertical cross sections, but it's also, this is our base, and our height is the same thing. So remember, so here's our cross section, here's another square. They're all different size squares, and then we're going to sum them from to pi. All right, so what is this length? Well, it's sine of pi minus sine of pi gives me 2 sine of pi, and that's our base. And our height's the same thing, so I'm going to square it. Okay? And that gives us our cross-sectional area. All right? But since it was, that was if it were a square, but I multiply it times pi over 8, and that converts it into a semicircle, which if I integrate it, I get pi squared over 4. Okay? All right, one more question on cross-sections perpendicular to the axis. I decided to try to demo on one that was between y is equal to x and cosine of x. I went and found on the graph that they intersected at 0.73908,513. Okay, so I'm just going to keep it in that region. All right, and cross sections perpendicular to the x-axis are equilateral triangles. All right, so my limits go from 0 to the 0.739. And I'm going to integrate the top one minus the bottom one squared. So it's cosine of x minus x quantity squared, and I put root 3 over 4 out front, and that would give it to me. Now I want to point out, if this were rotated around the x-axis and we were doing disk method, then it would be cosine squared minus x squared. That's what the difference is here. Okay? All right, so I hope this helped. Remember, for cross-sections, you got to make sure you remember how to do these, and then there was a work problem there. Hope this helps. Thanks. Bye.